Finding great candidates to hire can be like, well, trying to find a needle in a haystack. Sure, you can post your job to some job board, but then all you can do is hope the right person comes along. Which is why you should try ZipRecruiter for free at ZipRecruiter.com/post. ZipRecruiter doesn't depend on candidates finding you. It finds them for you. Its powerful technology identifies people with the right experience and actively invites them to apply to your job. You get qualified candidates fast. So while other companies might deliver a lot of hay, ZipRecruiter finds you what you're looking for. The needle in the haystack.
See why 4 out of 5 employers who post a job on ZipRecruiter get a quality candidate within the first day. ZipRecruiter, the smartest way to hire. And right now, you can try ZipRecruiter for free. That's right, free. At ZipRecruiter.com/post. That's ZipRecruiter.com/post. ZipRecruiter.com/post.
Hello and welcome to another episode of JavaScript Jabber. I have to say I'm especially excited about this episode because it falls in line with what I've been doing more recently, which is like a mixture of JavaScript and infrastructure. But anyways, enough of that. So I am coming at you from Nashville, and our panelists today, we have Steve Edwards.
Hi, and by the way, what's your name?
Oh, Amy Knight. Thank you. Sorry. I'm excited.
Hello, Steve coming at you from actually sunny and very cold Portland.
We have AJ O'Neill.
The thing I've been getting into recently is pomegranate juice with Mountain Dew.
That's a pick, isn't it?
That sounds interesting. I'm game to try that. Maybe Diet Mountain Dew. And our guest today is Christian Nunciato. You want to introduce yourself and maybe tell us a little bit about you?
Yeah. I'm Christian Nunciato. I'm a programmer. Been doing full stack development, mostly with JavaScript and kind of a little bit more front end than full stack for about 20 years or so now, a long time. And I work up here in Seattle on an open source project called Pulumi, which I'm also writing a book about. And so I'm just here today to talk about infrastructure as code and for developers and why we can begin to care about that and all that sort of thing. So that's what I'm here to talk about.
This episode is brought to you by Dexecure, a company that helps us developers optimize images, JS, HTML, fonts, videos on your own website automatically. With Dexecure, you no longer need to constantly chase new compression techniques. Let Dexecure do the work, and you can focus on what you love doing, building products and features. By integrating Dexecure in 10 minutes, you'll get a lower CDN bill, increased website traffic, and faster website than your competitors. Visit dexecure.com/JavaScriptJabber for a free trial, offering 20 gigabytes CDN bandwidth and 110,000 optimization requests free every month.
Awesome. We should probably start with a definition of infrastructure as code. And I'll let you take that and then I can maybe chime in.
Okay, well, it's kind of a biggish topic, but infrastructure as code is a way of describing and producing some infrastructural outcome with code of some kind. So whereas our normal practice as developers is often to go and create a virtual machine and sort of by hand and sign into that machine and configure it, install things on it, or go into a dashboard and create a database and configure that thing by hand using a web browser, for example, or actually install a machine somewhere in a rack or something. So infrastructure by hand is the way we've typically done it. Create computers and configure those computers at the command line with our hands in real time. Infrastructure as code takes a step back from that and allows us to use different kinds of tools to do all that work for us so that we don't have to do it by hand. We can write programs that we run with tools to produce those outcomes. So one of those tools is Pulumi. There are lots of other tools that do this in various ways, but that's sort of the high level definition is doing infrastructure things with computers and servers and databases and stuff, but with code and tools that run that code. Does that make sense?
Awesome. Yep. So one thing I'll add there too to that for people to kind of understand the why. I think one of the biggest whys when you first getting into this is people talk about environment drift, which is basically, when people were doing this by hand in the past, you really didn't have a way of knowing the current state of your infrastructure. And you had no way of reproducing that easily if something went down. Now we can just from the command line call out to an API in AWS or Google Cloud or Azure or whatever you're using and just easily create what you need. So my very first question, most of what I've been doing is in Terraform. Can you tell us like how, maybe I'll let you take what Terraform is, and then maybe I'll chime in with just like any beginner thoughts there. And then I'll also let you probably answer, how Pulumi, I can't say it.
Pulumi. You got it. Pulumi.
Pulumi. How Pulumi is different than Terraform.
Sure. So let's say that you have an idea for a thing that you want to build, a web application, for example, like a typical web application, and you know that you're going to need a virtual machine for that web application. This is just a typical example. You're going to want to put Node.js on it, for example. You're going to want to put some files on it, maybe have a web server on it and stuff. You're going to need to do something with that machine. Terraform is a tool that you can use to produce that for you. So earlier I described, I mentioned in infrastructure as code, you write programs and then run those programs with different tools to produce those infrastructural outcomes. Terraform is a command line tool, and it expects you to write little text files, basically. You can think of them as sort of JSON blocks, that describe the different parts of the infrastructure that you want to create. So if you were going to create this example web application, that might, the text blocks you might write for that would just be like 4 or 5 lines of JSON-like syntax that say, I want to use AWS. I want to use a virtual machine using this virtual machine image, like this base image with this set of properties. It should have a public IP address and things like that. You put 7 or 8 different properties into this block of text. You save that file as just a flat file, and then you run Terraform, pointing it at that file, and Terraform will then call out to Amazon Web Services to create that virtual machine for you. And when it's done, it'll give you the public IP address and all the stuff. Here are the keys to your virtual machine. Now go and sign into it. Does that make sense?
Yep. I guess one thing I'll add to that, in case people have looked at this before. So when you describe the JSON syntax, it's something called HCL, which is a HashiCorp configuration language. So I guess that actually brings me to the question. So is Pulumi basically a way that I no longer have to write HCL? Or am I wrong on that?
You can think. Yeah. It's Pulumi is you can think of it, and this is what brought me to it kind of early on. When I came to Pulumi, I had been using Terraform on a team at Chef. So I worked at Chef before starting to work on the Pulumi project on an application packaging platform. And we used Terraform to provision and manage all of the cloud infrastructure that we used to deliver that platform to users. And so we would write these HCL files. We'd run those files with Terraform, and it would create our virtual machines and our containers and all that stuff. And it was great. The language you described, this HCL language, is fine. It's just it's like, you can think of it like JSON, like I said. The thing about those files is that they kind of pile up over time. And if you aren't someone who's very familiar with the HCL syntax and what Terraform kind of expects of you, like as I was, as a developer, I was not familiar with it. And every time I would kind of have to come back to it, I had to kind of relearn it, brush up on it. So that was a bit of a pain for me, but I just sort of accepted it as a fact of life. But when I discovered Pulumi, the idea there was that you could sort of do all the same stuff that you're doing in Terraform, but do it with JavaScript or TypeScript.
That sounds absolutely amazing. I know with HCL, they have some logic that you can embed, but it's not as powerful as a language.
Yeah, for me that was all it took. I mean, when I saw that this thing existed, I was like, I got to go work on that thing, because that is the thing that I've wanted to exist for 10 years, and now it exists. So you can very much think of it like Terraform, but if you're familiar with Terraform, you can think of it like Terraform, but with whatever language you want to use. I mean, a subset of languages. There's JavaScript and TypeScript, of course, and then the .NET family of languages. If you're a .NET person, you can use C# or VB or F# or Go or Python, stuff like that. So.
I have one more super quick question. I know Steve has a question. So is this completely independent of Terraform? You don't leverage Terraform at all?
Yeah. So it's built on top of the Terraform providers, which are basically like clients. Yeah. They're open source API clients that know how to talk to AWS and Azure and Google Cloud and all of that.
Yeah.
So we do for a handful of the major cloud providers, because so many humans have spent so much time building those API clients. They're just solid and reliable. And so many of our libraries are built on top of those Terraform cloud clients, basically. Yeah. So we don't use the Terraform tool itself. We just we definitely leverage some of those API clients, because they're, like I said, they're pretty good.
Yeah, that's what I was going to say. That even makes me like more so excited about it, because knowing that, you're already, it sounds like it just would like allow you to build even more, and you're not having to like recreate something that's already been created. But anyways, I should let Steve jump in.
So I'm going to play the role of the clueless when it comes to infrastructure person who just does the web development and lets other people set up their background for them. So we're talking about, Terraform and Pulumi and how you automate your infrastructure setup. So how does something like this compare to, say, Docker? Okay, are they grapes and watermelons completely separate? Are they, and say Kubernetes as well? Are they sort of related, not related at all? Because that's what I think of automating things, because you can script a Docker container and have all your stuff in it and so on. Does that make sense? Just trying to get my head around, relate what you guys are talking about versus the little that I know of infrastructure, and I'm sure many other people know as just as little as I do.
Yeah. Assuming that you know what Docker does, like assuming you're, and I know that many developers are so super new to this that in itself is kind of a new concept. But assuming that you know that you can write this Docker file to create a Docker image and run that image and create a container from it and so on, and then inside of that container, some stuff can run in various ways. You can either create a service that listens on a particular port, or you can just run some command and so on. A Docker container is just a runnable thing. That thing has to run somewhere. Sometimes it runs on your local machine. Sometimes it runs in a cloud like DigitalOcean or AWS in various ways. So Pulumi is a tool that you would use to kind of direct the places, create the places where that container would run. So if you wanted to run that container image in AWS, you would use Pulumi to write a program that says what you want to use in AWS to run that container. So your program would describe, what AWS services you want to use to run that container, for example. Does that make sense?
Yeah, absolutely.
Yeah.
So now you've been mentioning AWS. Is this specific to AWS, or could it work on something like Azure or Google Cloud Platform or some of the other providers like that?
Pulumi runs on all the major cloud providers. And so Azure and Google Cloud and DigitalOcean, AWS, of course. The book I'm writing is very AWS centric. So it's, AWS is a very popular example and very popular among our users. I think a significant portion of our users are just using AWS, but it runs on any major cloud provider. And on top of that, there are also you can write your own providers if you so choose. So if you encounter something that, say, isn't supported yet by Pulumi, you can, like, say, if you had a cloud provider that was sort of just up and coming and a provider didn't exist in the open source community for it yet, you could write one of those yourself in a couple of different ways. So it's kind of provider agnostic in that sense.
What is Pulumi itself written in? Is it Go or something else?
Go. Yeah, that's correct. Yeah. And there are various components, but the major components are all written in Go. And then as a developer, when you use it, if you're a JavaScript developer, the programs that you would write are JavaScript programs that run on Node.js. But if you're writing, say, if you wanted to use C# or some other language, you could write the programs in a different language using libraries that are specific to that language. So when you're interacting with Pulumi, whatever language you're doing it in, the idea and the intent of Pulumi is to let you manage that infrastructure in a way that's comfortable to you. This has been the biggest pain for developers entering the world of infrastructure, is all these tools are totally foreign and strange. And I'm not familiar with what these tools expect of me. I don't think in their terms and so on. And so the idea with Pulumi is to bring that up to the level developers are comfortable working with. And so that definitely is what drew me to the project originally.
It's just I don't know. I have so many questions and thoughts. One of my pain points that I've been having, or I don't know, as a JavaScript developer, when I'm writing HCL, one thing that pains me is I can't lint I think there are some linters out there, but not to the level that I'm used to. If I'm creating, variables in HCL, I can't lint for, unused variables. One thing I was looking at is kind of trying to write my own, because it bugs me that much. I'm just very much a clean code, really like to keep everything neat and tidy, and that's been bugging me. So, and then one thing I haven't really done much of with infrastructure as code is testing. So I imagine the world of linting and testing is probably a lot better too.
Yeah, if you're comfortable working in VS Code, writing JavaScript programs or TypeScript programs, especially in VS Code, you just get all of that goodness for free. the Pulumi libraries are typed really well. So you can, not only can you write programs that, easily detect things like you described, like unused variables and things like that. And because you're writing in JavaScript, you can write tests around that stuff using the standard tools that you're already familiar with. But you also, you get all of the type hinting and such for all of the cloud platforms too. So not only do you get to do that stuff with your own platform, but you can sort of you can say, var foo equals new AWS S3 bucket, and then bucket dot, and then you get a type hinting that kind of exposes all of the S3 infrastructure to you, or API surface to you.
That would be amazing.
Which is great because as we know, the easy part is the hard part is API surfaces are massive. AWS is like awesome, but the worst at this because it's just so huge. There's so much of it. And so to have that developer focused experience is really, it just changes the whole experience for us, as it has for me.
Yeah, because I feel like whenever I'm doing anything in Terraform, I always have three things open. I have my editor open. I have I do a lot in GCP, so I have the GCP docs open, and then I have the Terraform docs open. And it's always usually a mental mapping going back and forth between what does this attribute that I have in Terraform, what does that equate to in the GCP docs, and to be able to have some of that hinting would be amazing.
So in one way, this sounds like the age-old argument of imperative versus declarative. The industry waffles back and forth on this every 6 months,
Yeah.
And so this sounds like we're saying, actually, it turns out the declarative, meaning data-based or markup language-based configuration, is hard. Let's switch back to declarative, meaning line-by-line scripting or programming-based configuration.
Yeah, this is where it gets kind of interesting, and because Pulumi, even though you're writing it in an imperative language, say if you're using TypeScript or JavaScript, what you're producing is actually a declarative thing at the end. And this is a bit in the weeds, but declarative is basically correct. I think everybody sort of, in most ways, what you want, I think ultimately is a way to express what the end result should be. And so at the end of the day, when I run my program and I produce my infrastructure, it should have, a virtual machine and a database, and they should be configured to talk to one another. And the virtual machine should be accessible over the public internet. And you want to sort of be able to utter that in some way. And that is that concept is a declarative thing. You could draw it out. You could sort of draw an architecture diagram, for example, that described the end result of what you wanted to get at. So I think that still holds. I think we still kind of want that to be. The difference between Terraform and Pulumi is that with Terraform, largely what you're doing is writing that out in text for the most part. There's some logical constructs you can use to do loops and things like that. But for the most part, you're writing out the declarative thing in a mostly statically expressed way. When you're writing a Pulumi program, you can write it that way. But what we often end up doing is we need those of us that have come to sort of Pulumi, for example, from Terraform, we needed those logical constructs to be able to capture more complicated rules that we wanted to apply to the creation of that infrastructure. So when you're writing a Pulumi, but at the end of the day, you still need a declarative thing. You still need a kind of an end state that needs to be expressible.
I'm not saying that one is better than the other.
Yeah,
but this is not declarative from what I'm seeing on the pulumi.com/product. That's not declarative. That's imperative because you're writing code. Now, does it produce a config file or whatever? Well, sure, but it's producing it for 6 different platforms or services or whatever, right? So, to shoot straight, it's imperative. Not that that's a good thing or a bad thing.
Yes.
That's what it is.
It's totally, what I was getting at was you're totally right. I think you are expressing it imperatively, 100%. It's just that the subtlety.
Well, you could say that about anything, right? All code ends up as something that you could at some point call declarative. If we look at machine code, we could say, this I don't know, you will put it in XML. Now it's declarative.
Right. Yeah.
Anyway.
Yes.
So getting back to trying to understand what's going on here. So I see that there's an aws.ec2 in the example on the homepage. aws.ec2, aws.eks, kates.service. So are these libraries provided by Pulumi, and this is what is ultimately generating those config files? Or is this talking directly to, is this actually the AWS SDK doing AWS things and the Kate's SDK doing Kate's things?
It's Pulumi libraries are what would do that for you. So like the libraries do package up and the AWS SDK for you to use if you want to use it, and very imperatively to do things that you might do with the AWS command line, but in JavaScript, you can do that inside a Pulumi program using the kind of bundled AWS SDK.
Well, but when I looking at this thing that says aws.ec2.vpc, EKSnet, is that the official AWS SDK, or is that a wrapper that's provided by Pulumi to create config?
It's the second thing. Those are Pulumi classes and types and things that are what expose the surface, the API surface of, say, AWS or Kubernetes or whatever to you as a developer. But those are Pulumi libraries. Yeah, those are the open source Pulumi libraries that you can download off of NPM or GitHub or what have you.
Okay. All right. So I think I kind of, gosh, there's just so many pieces to all this stuff. Like, I mean, because you gotta set up DNS so that it points to a server. You gotta tell the server that it needs to have a database. You gotta, I mean, I'm just trying to imagine.
Yeah. Sorry, I didn't mean to cut you off.
No, it's fine. I'm just looking at the examples and I'm just trying to think like, I don't know. This is one of those problems where my fear with things like this, and it's just the layers of abstraction that you run into. But I mean, I think the same thing is true with Terraform and other stuff. It's just, there ends up being a lot of layers because you're defining your infrastructure, but at some point your infrastructure has to, connect with something that's accessible to people. There's always variables. Like there's always something that requires a human to come in and say, like, this is what I want. Well, a human has to write this stuff in the first place. But like this, what I see in the examples is config for the infrastructure, the platform, the hardware, the software, the services. Does this also define how you connect that to domains that a user interfaces with, or is that done somewhere else? I don't know if that question was clear.
Yeah, if you're describing like, if what you mean is, when you go, if you have a virtual machine, say, and you want that virtual machine to be running a service that you can access over a certain domain name, is that what you mean? Is that what you're describing, or did I misunderstand?
Yes, but I may not be asking the right question because I'm coming from the perspective that, like, if I set up a service, the reason I'm setting up a service is because there's going to be an end user that's using it, but that may not be the case. I'm sure there's tons of services that are just purely on private networking, and they do like internal things that maybe through another service get exposed to a user at some point, but maybe not the initial service does. Like, if you've got some sort of machine learning, that's the buzzword of the day, but some big machine learning platform that's behind the scenes on a private network, and you've got some web interface somewhere that connects in and then fires off a batch job, and then it goes into an SQS queue, and then it gets consumed by this thing that's completely private that never sees the light of the internet. And so I guess I am asking that question of like, how much of this is geared towards stuff that's like internal that doesn't see the light of day, and how much of it is geared towards stuff that's external, or is it both? Yeah, I'm sorry, I'm totally muddying up what I'm saying, but hopefully even less clear than it was before.
Yeah, I mean, in some ways there are so many ways, and this gets into areas that even as a person who uses these tools all the time, I don't know. There are many ways, of course, that you can use like AWS, semi-privately co-located, things like that. So if that's kind of what you're getting at, like the idea still is that in a given program, you should be able to describe all of those pieces and their relationships in code. You should be able to say, you should be able to write a class or an object that describes the network, for example, and then you should be able to write another class that can accept, maybe when it's instantiated, a reference to that network so that it can get created in the proper place. You see what I'm getting at? So like you should be able to express all of this stuff with a given programming language in a way that makes sense to you and that can be understood by other humans,
I get that. It's like, So this looks like it's describing an instance of the thing. Like, so for example, I have example.com is my production site. And then I've got examplebeta.com is my beta site. And staging.example.com is my staging site. Mm-hmm. And I'm imagining, and maybe I'm thinking about this wrong, but I'm imagining you run this and then you have an instance of infrastructure that has all the pieces. And so it's like, if I wanted to spin up staging2.example.com, I could use this exact same config file. And then I'd like tweak one variable to say the domain that all of this should end up connecting to is staging2.example.com. And I run it. And then 15 minutes later, or 10 seconds later, or however long it is later, I have staging2.example.com that is an exact replica of what example.com is, or what staging.example.com is, or what examplebeta.com is.
Mm-hmm. Yes. So what you've described is exactly the goal of Pulumi is made to do. And so that, like, what you described is what Pulumi calls stacks, which are basically collections of infrastructure that are produced from a program. So the idea is exactly as you describe. Hey, I just want to write a single program that describes, my website, you know what I mean, and all the parts of that website. And I want a dev version of that I can hack away on and mess with and tear down when I'm finished. I want a production version of that that's based on the same exact code. It's produced from the same program. I want a staging version. I want a test version. And each of those is what is called a Pulumi stack. So when you run a Pulumi program, you produce a stack or a collection of cloud resources. And so as you describe, each stack has its own configuration file. And so it's like a YAML file. And so you might say the YAML file, the config file for my dev stack is, dev.aj.com. And then, the production one is just www.aj.com and so on. So that the
I would never put a www in front of something. How dare you?
Pardon me. Yeah. But so the way you describe it is exactly how it does work. And because I think by and large, this is kind of how we think of things, So.
Okay. I think I get it. I think what you're getting, what you're saying is making sense for me. So generally, okay, if I've got something in production, I don't want the database to be recreated. I don't want to redeploy production. I want something to update in production.
Right.
So, and maybe I'm getting too deep into what this tool is and what it does, but it makes total sense if I'm going to say, like, I want to spin up something new that didn't exist before. I want staging3.example.com. But what doesn't make sense to me is if I ran this on example.com, bye-bye database. I mean, like, what's the process to update or make sure that there's not like 15 minutes of downtime while this is running and recreating? Like, how does the update or the deploy new feature process work with this?
Yeah, if you're familiar with Terraform, it works just like Terraform.
And I'm really not. I gotta be honest.
Yeah. To take a step back from that, there's an approach to infrastructure as code. We talk about declarative infrastructure as code. I want to describe what the outcome should be in a program or a text file or something like that. This is what the topology should be at the end of the day. The idea with tools like Pulumi is that they are called desired state tools. And so their purpose is to produce an end result, a graph, like a config file, as you described earlier, so to speak, that says what that end state should be. When you run it for the first time and say, that file contains an RDS database, a virtual machine, a bunch of stuff, you run it for the first time, Pulumi will go out and create all those things for you. If you run it immediately thereafter, nothing will happen because the desired state that program describes will have already been achieved. Does that make sense? So like you can run it against production all day long. And if nothing has changed in the program to produce a different status sort of in the end result, then nothing will happen. So this is why it's sort of like popular to run these tools in continuous integration delivery environments, because they can just keep on running. And as long as, like, until anything changes, just nothing will happen. But when just one little thing changes, then only that one little thing changes. Does that make sense?
Yeah, well, yes and no, because the caching problem. Like it seems like knowing that something has changed is one of the fundamentally catastrophic misunderstandings of computers in the world.
Mm-hmm.
So, like, I would imagine if I push new code to master and I merge it into production, then, it could have a beat on that something has changed. And so therefore it should run the rebuild and redeploy process and do some sort of like graceful restart. I imagine there's some way that it can like start up a new instance and then register that the old instance should be taken offline when connections are severed, or maybe that's just part of the cloud platform, the EKS and whatnot, or ECS, EC2, blah, 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 blah.
It's so confusing.
No, it is EKS, right?
So many things. Yeah. Well, yeah, there is an EKS. Yeah.
I'm just trying to, one of them handles that, I think, that particular process of like you spin up a new server and you let the old server die. So both the old and the new server persist for some amount of time while it's changing out.
Correct. Yeah. So the way that Pulumi works, for example, is that if let's say that you need to make a change that results in, let's say, like, take the database, for example. Like, this is maybe not a great example, but like, for example, if you have a database, you've used Pulumi to write a program that creates an RDS database, for example, and for some reason, the update that you're about to make is going to require that database be destroyed. Like, it has to be replaced with a new one. In that case, Pulumi will do by default, unless you tell it otherwise, is it will create the new thing before destroying the old thing. And if that old thing was connected to other things, Pulumi will connect the new thing to the other things before destroying the old thing. Does that make sense?
That was super clear. There's the thing and the thing, and when it connects the things, then the things can get connected. Got it. Crystal.
So, but that concept of create before delete is where you get zero downtime, which is kind of important to some people. And so that's how it works by default. You can make it not do that for some reason, but if you just use it the way that the APIs guide you, your new infrastructure will be created before the old infrastructure is destroyed.
And the good news is that all the problems, it's easy to test them out, hopefully, in the beta and staging environment, so that if there is some problem where the new version of Redis is somehow slightly ever so incompatible with something that you've got set up in the old version of Redis, that you're going to catch that before it goes into production, and it's not going to be a problem.
Right. Yeah. I mean, this is why it's super valuable to have all of your infrastructure expressed in code and therefore, in Git and reviewable by other humans and continuously delivered by automated processes. Because if you've got, you want to make sure that you have the same version of Redis or whatever it is running in all the environments, the exact same version, because for those to fall out of sync, as kind of like creates the possibility for mishap. So what you describe is exactly right. You want to, ideally, you have multiple environments, multiple Pulumi stacks, so to speak, multiple environments running all the same stuff, so that when you merge something, say, into an environment that is not your production environment, certain problems with those configurations get surfaced immediately and non-catastrophically. So that's the whole idea, to let you deploy lots of things really often and really safely.
I like that.
Yeah,
I like the non-catastrophic part. That's
yeah. And this is tricky too, because part of the, when say a tool like Pulumi and other even tools like Terraform, when they run, they need to sort of interpret what you've written in your program, and then compute the changes that have to take place on the infrastructure based on what its best guess. And so the way that works is the tools need to rely on some concept of the last known good state of what the infrastructure was in order to figure out what the changes ought to be. And this is where it gets kind of dicey when you can run tools like Pulumi and Terraform and others in a way that will produce an actual file, like a state file, at the end of a run. So if you write a Terraform program or a Pulumi program and you run it, when that is finished, that infrastructure as code tool will kind of take a snapshot, so to speak, of what the end result was. The environment that I just deployed has this virtual machine with this ID in it, and this database of this IP address, and all that stuff is captured in a state file. So literally a big old JSON file. That file needs to be, whoever runs Terraform next with that program or Pulumi next with that program needs that file. They need to know what the last known good state was, because that run will then decide what it needs to do based on the last known good state of the infrastructure. So
so it's not querying the infrastructure to determine the truest, most real version of the state. It's relying on the fact that you didn't do a cowboy hotfix to something.
Correct. If you do the cowboy hotfix, there's no notion of that captured anywhere except at the infrastructure layer, except in AWS. So if you go into like Route 53 or something, and you change some DNS settings, and you have a program that was initially responsible for creating those DNS settings, you have a problem. So that reconciliation needs to happen. Now, there are ways that you can ask Pulumi and other, like Pulumi Terraform, so on, to give me the most recent version based on from the provider's perspective. So you can do what's called like a refresh with Pulumi. Literally, it's a command that's Pulumi refresh, and it will go out and ask AWS, for example, or whatever other provider, here are the things my program cares about. Has anything changed? And if so, give me the changes, and it will then incorporate those changes into the last known good state before you run it again as a safety. So there are ways to kind of assist with this, but still, the thing that is used to determine the set of changes to be made is a snapshot of some kind. So where that snapshot lives is often pretty important.
Hey, you know how your ops team keeps a pile of scripts and wiki documents explaining how to perform those routine and emergency tasks that keep your applications running? They might call them runbooks or playbooks. Our friends at Octopus Deploy were thinking DevOps is about collaboration, so doesn't it make sense for runbooks to be automated from the same place as deployments? Well, Octopus Deploy is now the first deployment tool with native runbook support. And the best thing is your runbooks can share configuration settings and automation steps with your deployments. So go find out more at octopus.com.
Okay, so let's say that let's define the person that most needs this information that we're talking about. Because it seems like most of the time you come into something that exists and you're just sitting there and you're trying to make choices to help the team or yourself or whatever get things more manageable. So what is the ideal state of a person and a company when they would be looking at Pulumi or something like it and say, now is the time that we're going to start using this type of thing, or now is the time that we're going to migrate specifically to Pulumi? What might that look like in terms of company size or developer role, or that? What's the state of the universe when that is the aha choice to be had?
Yeah, well, I mean, in some ways, like I'm biased because I would never, if I can provision and create some infrastructure with code, even me myself, like I'm like a dad. I got a website that I post pictures of my kids on. I write the infrastructure as code to produce that website because I don't want to have to manage everything manually on my own. That's only one little thing of my own. I could certainly do that. I could just go into AWS and put buttons and things like that to go and produce my S3 buckets and things like that to hold my website. But I would much rather express that in code so that I can always have a reliable, consistent outcome, and I can continuously deliver with GitHub Actions and things like that, and just have it work. So like even for small teams and even for individuals, it makes a lot of sense to try to do this if you can very early on. It's much harder to do later because you've got a bunch of infrastructure that's kind of already out there and running. You can import that infrastructure into programs, but it's a lot harder to do that. So my answer to that question is kind of like as early as possible. If you believe in these concepts and you can find a tool that you like, I would advocate pretty strongly for writing infrastructure as code from the very beginning if you can, just because as you grow, it will become harder and harder to manage that stuff by hand, much more error prone. And that just creates problems and wastes people's time and kind of also has them doing things that they kind of would most of the time rather not do. You know what I mean? So does that kind of answer that question?
I'm going to go with no, actually.
Okay.
Because you're saying, well, everyone should use this all the time. And I'm just going to push back on that because I don't think that's true. I don't think that anybody that wants to host their blog should go through the effort of learning AWS stack and put things in S3 buckets. I think they should use rsync, put it in the server path, and let it be.
Yeah.
You get Caddy or Netlify or, and you put some files and you get push and you're done.
Totally.
Or you rsync and you're done. So I want a more thoughtful answer than it's the panacea that everybody should use at all times.
Yeah. I mean, I totally, yeah. I feel a little bad even, talking to developers who already have, we have so much stuff that we have to learn as it is. And to sort of say, now go off and learn all there is about infrastructure is sort of like, oh my God, when I've spoken to others before, this is what I get resistance because it's like, man, I'm interested in this. I would love to do this, but it's just a lot to bite off. And it truly is. It really is like that. So I 100% agree. And I would say that to the extent that you are interested in doing this, these tools will help make it easier for you. I don't have a great answer to your question other than,
well, how do I sell it to my manager? Right.
Yeah.
I go into work today, I listen to the podcast. I'm convinced we have problems. We have reliability problems. We have deployment problems. I know this because I'm on the team. I see it. And I'm saying, okay, I think that I should go check out Pulumi or Terraform or both or whatever and make a decision and bring this up the ladder. What might that experience look like? Could you maybe think it from that perspective?
Yeah. I mean, anytime you're collaborating with other people, as just as a developer, it's best when you can when you can use code, or it goes well, I guess I would say, when you can use code to communicate with one another, code and Git and code reviews and stuff. This is sort of patterns that we've just become comfortable with. I assume most of us are comfortable with this whole idea of collaborating with other technical people in code. So anytime you're in a team of people that is going to be interested in anything related to your infrastructure, doing that in code is just going to be more understandable by people and more manageable and so on. So certainly in team environments, it is a good practice to do as much as you can do in code. And so, whereas to leave it to individual developers to kind of manage this stuff manually, certainly doable. Like I said, especially at a small scale. I don't want to kind of convey this is the only way that it doesn't make sense to do it any other way. It's certainly reasonable to, on a small scale, kind of, work in dashboards and things like that. The overall point though, is that when you do that, it's just a lot easier to make mistakes, to spend a lot of time doing things by hand that you would probably rather spend your time using for other reasons. And when you do all of this stuff by hand, try to manage it all by hand, even if your job is entirely to manage this stuff by hand, you still have situations where environments may differ slightly because, in prod we want to kind of, configure things slightly differently than in staging or in dev. And so these environmental differences create potential for confusion and mishap, as I said earlier, and so on. So in team environments, this is kind of just the way that it's much more reliable and consistent to use code-based tools to produce these outcomes than it is by hand. I think just at the end of the day, too much can go wrong too easily when you're managing things manually. Make sense?
Yeah, that makes sense. Yeah. I get that reasoning.
But I just want to just reiterate, it's I can say this because I've been doing this for 10 years. And so to me, I'm comfortable in this area, but somebody that is new to this it's a lot. I mean, it's a lot to ask of anyone who's already got a ton of stuff that they're trying to absorb just to do their actual application development job. Now I got to go and think about infrastructure and all these other infrastructure tools and declarative versus imperative and all this stuff. It's
the declarative versus imperative, you got to fight that battle at some point. You got to get the sword out and have words at some point, because everybody's got, well, not everybody, but on any team, somebody is going to have a strong opinion about that.
Yeah. But the thing about Pulumi, I think that kind of is great, and what led me to work on it. I mean, I was driven to go and work on this thing because, it makes this for a developer about as easy as it can be and familiar as it can be. Because like I said, you're using a language that you already know that, and when you do that, when you do kind of get that kind of leg up or toehold into the cloud with that language that you already know, it opens up a lot of interesting possibilities for ways of building applications that you may not have even thought of, which was the case for me. When I came to Pulumi and I started using it, I was like, cool, I can do Terraform things, but with TypeScript, I'm in. But what I didn't realize was that when you start to compose with the kind of application oriented parts of the cloud, you can write programs that are very different from the types of programs that you're used to writing with like, running services, long running services on virtual machines, for example. That kind of way of composing applications shifts in a major way when you start using quote unquote cloud native ways of composing that are a lot easier to do in a program and a lot harder to do by hand, because there's so much stuff in, like, for example, the AWS console that you have to go and manage by hand in that way of thinking. But when you can use these tools to compose in that way, it opens a ton of opportunity for you as a developer, not professionally, certainly professionally, but also just creatively, that you just didn't have before, because, it's a whole other way of working. Does that make sense?
Yes. Perchance, does this support DigitalOcean?
Absolutely, yeah. So DigitalOcean and DNSimple and sort of all those other things, GitHub, so you can write a program in Pulumi that pulls in some of AWS, pulls in some of DigitalOcean, pulls in some DNSimple, pulls in some GitHub, whatever. And because you're just using JavaScript libraries, for example, that abstract all of those providers as like TypeScript classes and things like that. So absolutely, yes. That's where it becomes really, really great, is that if you don't want to use, say, the DNS provider that AWS provides, you want to use yours or something else, you can do that in a single program. You can express that in a single program.
All right.
Yeah.
So I got, I think, 2 more questions. One I just slipped off of my mind, so I'll go with the other one. So looking at Pulumi, it's $50 a month, $225 a month, enterprise, call us, community free. So I'm a little bit more confused about what Pulumi is, because I thought Pulumi was a command line tool, and that it's just interfacing with AWS. So I'm going to create some environment file that has my AWS keys or my DigitalOcean keys, apparently, which That's awesome, because I love DigitalOcean because it's really simple. Like, I feel like anybody who has some basic knowledge of how the internet works can go into the DigitalOcean console and get to work. Whereas AWS, it's like, you got to go get your degree, your bachelor's in AWS before you can figure out what the heck's going on.
Yeah.
So anyway, so I'm thinking of it as a tool like that. That's what we've been discussing. But then I come here and there's a pricing page. What the heck is that about? Like, am I paying for the command line tool, or what am I paying for?
Not at all. No. So there are, what you're paying for. Remember earlier I mentioned the state snapshots that are produced at the end of, say, a Pulumi run or a Terraform run. You have this file that describes the last known good state of the infrastructure.
Yes.
That file needs to live somewhere. And so what people will often do is may use an S3 bucket or something to store that file, so that if I run Pulumi on my machine, I can run it in such a way that it will request that file from the S3 bucket and use that as the last known good state. And if you're on my team and you want to run Pulumi with my program, you can use that same S3 bucket to query the last known good state so that we can work together. Okay. That's entirely free. That idea of a state file that is either managed on your local computer or in some remote data store that multiple people can use is entirely free. The other way that you can use Pulumi is it has a service component, which you can use if you want, to store that file for you, and also keep track of your runs over time, your updates over time to your infrastructure, and the diffs that changed between runs and all of that stuff. If you want to use that service, you are welcome to use that service as an individual, just a hosted free service. As an individual, you can use that for free forever for as many stacks or projects or whatever as you want. If you want to use Pulumi in a team setting and use the service as your backing store, then you pay for the number of people that are using it on your team, for example. So that's where the commercial aspect comes in. That's how Pulumi makes its money, is by teams using it in ways that have the service manage the state files instead of sort of managing that on your own, which you can totally do. It's just a little easier, a little nicer, and you get the kind of historical change stuff in the service as part of that. Also, locking is important. So if I'm running my program and you're running your program at the same time, that can be a little tricky to handle when we're kind of manually managing our state files on our own. but the service will kind of handle that locking for you and prevent multiple updates from happening at the same time and things like that also. So,
that actually reminds me of my other question, which is, so if I create something, say on DigitalOcean or on Amazon or wherever, I'm going to get back an IP address. And so if I'm going to update some DNS records, I can't know what the DNS records are. Like I literally couldn't create a quote unquote declarative file myself because the IP address doesn't exist until I've created the service that the IP address is connected to. Mm-hmm. So how is this handling things like that, where you're talking to different services and, you say, go create a server and go update this thing, but the pieces that need to be connected don't exist yet until the configuration is run.
Right. And one thing you can do in your program is, let's say that you have a virtual machine and a DNS record, in your program. You just have two parts. I want a virtual machine, I have a DNS record. And the DNS record should use the IP address that is produced by the virtual machine. That speaks to the scenario you're thinking, right?
Yeah, exactly.
Yeah. So then the way that this works is, and it's hard to do this without showing code, but the block of code, the instance declaration, you say like new aws.ec2.image, or not image, instance, and you pass it some parameters, but when you do that, you create a variable that holds on to a reference to that object that was created from that class, that Pulumi class. So you say var foo equals new EC2 instance, and then you have foo, right? That is sort of the variable that contains a reference to your AWS virtual machine, which has not yet been created. A couple lines down, you can write your, var bar equals new DNS record from DN simple or something, whatever it is. And as part of the IP address input to that DN simple resource declaration, you can say, for the IP address, foo.ip or foo.public IP, and pass that variable reference to the creation command, or sort of the instantiation of the DNS record. Does that make sense? And when the program runs, it will compile all this stuff together and say, oh, okay, the DNS record relies on the virtual machine, so I need to make sure that thing exists first.
And it sounds like there's not too much abstraction at this level. Like if I'm using the config wrapper library for AWS or DigitalOcean, it's going to be pretty specific to that, not made generic. So I'm going to get the exact details for what, because an AWS EC2 instance, like the JSON that comes back from the API or the XML that comes back from the API on that is different from the JSON that comes back from the API on DigitalOcean, or the XML that comes back from Azure, or whatever it is. So it sounds like these are specific to the provider, not abstracted. Is that correct?
Yeah, but you can still use that to the extent that those properties are kind of primitive properties, like the outputted IP address of the virtual machine instance that was created on EC2 is a string, for example.
Yeah.
And then the input to the DN simple record or whatever is also a string. Then you can that works just fine. So
I actually like the idea that it is not abstracting that part away, that it's so this is not a tool that you'd use if you want to do a quick, because there's some tools out there that's like, oh, you can use this with Amazon, but then if you just switch a config file, then you can use it with Azure. And so there's this theory that you could just switch from Amazon to Azure with a config file change. This, you would go through and you'd rewrite all of your code for Azure, or Amazon, you'd have to rewrite it for Azure or whatever, which I think is, you don't normally change these things. And when you do, it's for a particular reason. It's a lot easier if things map to the documentation of the service rather than an abstracted documentation in many cases. So that makes sense to me.
Yeah. And the thing about this, though, that you can go a step further. So let's say that let's say that you're programming to, your API that you want is a website, like a very high level abstraction website, and a config, you can, because we're writing in JavaScript, you could go that extra level. You as the developer of the infrastructure code could say, write the first version of that high level website abstraction to use AWS, but you could also then write another version of that used Azure, and then you could write your high-level class, for example, to just take a param that says Azure or AWS, and you pass in Azure, and it goes out and uses your Azure-specific module to create the infrastructure, or your AWS.
Is there like a cookbook, or, I mean, it seems like that's something that somebody would probably do pretty early on. Is there something like that already that's like a community, somebody on GitHub has a Pulumi abstract VPS service module?
Yeah, there are a couple of those. Yeah, I don't know. I think it's more common, as you say, that like, you're going to pick a provider and kind of use that provider. I think there may be a couple blog posts on the Pulumi blog that kind of show how this is done. But I think it's the kind of thing that, like, if you're comfortable writing, classes and so on, you could probably write that yourself. You kind of know both clouds, of course, that's the real pain, is like knowing how to do something that you did in AWS also in Azure, because the clouds themselves are so different these days too.
And the nomenclature and
so that's a hard problem, but because it's programming languages, it's all easily solvable, but it's
The question I was going to ask really quickly when we were talking about the remote state, I feel like most places that I've seen usually just typically, if it's if they're interacting mostly with AWS, they'll store their stuff in the S3 bucket. If they're using GCP, then, cloud storage. But is there a benefit to storing it with Pulumi versus like the provider I'd be using?
The couple of the benefits I mentioned are just that, the Pulumi service will keep track of all of the changes to a particular stack or environment over time. So if that's something that you're interested in keeping kind of a historical, view on, that's super valuable. The other reason is one of the other reasons, I guess, is also locking, as I described. If you have multiple people that are using the same Pulumi program, then the service will handle making sure that no one is stomping on one another by running at the same time. And then you can also apply more granular access levels to things. So if you're kind of on a team that manages or that wants to manage, what different developers on other teams have access to, you can do that really easily in the service by just, adding groups and permissions at the stack level and stuff like that. So role-based access controls or whatever like that, that's easy to do in the service also. So those are a few of the reasons why you might want to use the service. Yeah. But again, like, all this stuff is doable as you describe. Like, it's kind of open source and free by default. But if you want kind of more teamy things and more permissions, granularity, and policy checks and things like that, then you can use the service to make that easier for you. But I think you get to a certain point in your team development where that becomes useful, and you don't necessarily need to start out there. Although it is really easy to start out there, and it's kind of nice, but you don't have to do that.
Awesome. I'm already pinging people and asking if the team has kind of like looked into this or not before. So, because I'm made up of a team of like a lot of just like hardcore, infrastructure engineers, but then there's two people that come from a dev background. So I think for him and I, we're really excited about it. But the infrastructure engineers usually want to like up their chops on, like application development. So this might be a good way for them to do that too. But anyways, it sounds like we don't have any other questions. Is there anything that you want to share before we get into picks?
No, I mean, I think that's just just to reiterate, I mean, like, as a developer myself who kind of discovered this just a couple of years ago, I really am excited about, and this is the reason why I chose to even write a book, which is like a huge pain. I mean, if you've ever written a book, it actually takes a lot of time, much more time than you think it ever would. But I still believe in this idea that for us as developers, this is a really useful and powerful tool that kind of allows us to do a lot more than we could ever really do before with a language that we really love. That's why I'm so happy to speak to this group, because like, I'm in this group of JavaScript developers, and this is good stuff. So we should take a look. There are other tools out there too, by the way. Like, Pulumi isn't the only one. There's a tool called AWS CDK, or Cloud Development Kit, which is a JavaScript-based tool that you can use if you just want to only do AWS things. So there's more and more JavaScript-oriented tools that are beginning to emerge for developers. But I think Pulumi is really it's a great one. It really kind of opens a ton of possibility to you. And so I would just encourage people to like, be brave, use the type hinting in VS Code, and go forth and have some fun. So
I should have asked one other question that came to mind as you were saying that. I'm curious, have you guys seen like one of the languages be more popular among users versus others? I'm just curious.
Yeah, I mean, the TypeScript language is definitely the most popular.
Interesting.
Because it's just the most. The JavaScript being like the flexible language that it is, there's so much that we can do there. When we didn't talk much about like AWS Lambda or API Gateway and that kind of stuff like that, when you're using JavaScript and TypeScript, the ability to write inline functions that ultimately get like serialized into AWS Lambdas and things like that, that's absolutely delightful to do in TypeScript and JavaScript. It's a little harder to do in some of the other languages just because of the nature of those languages and the way that AWS kind of expects you to use it. So definitely TypeScript, I think, is our most popular language. Also the APIs are the most developed. But I think we're seeing a lot more uptake in Go also, particularly infrastructure teams that are familiar with Go. They'll pick up Go. Python is also pretty popular. .NET folks are kind of coming on gradually. So C# kind of bringing up the fourth level there. But yeah, for sure, JavaScript and TypeScript are kind of across the board the most popular still.
So I'm going to circle back around to the question I asked earlier about, what's the ideal state? I'm just looking at the price of this, and I want to hear if you can make a better argument. But I'm thinking like if I buy a car for $2,000, I'm not going to spend $2,000 on tires because they're an accessory to the car. And, I equate value of accessories are usually in the realm of, 10% or something of what the cost of the thing is. Maybe you could challenge me on that with like game consoles and controllers, which end up costing about the same as the console when you're done. But anyway, so I'm thinking if a team is spending $500 or more in infrastructure cost currently, that might be a good frame of when they're at a level of production that it would make sense to transition into something like this, just based on the price. If it's going to cost me $50 to get started with a team of 3 members, then as an accessory to my services, then, maybe if I'm spending around $500 or more, that would be a time where this would be like, I'm at the level where I'd be really productive, or this would be worth getting into. Do you have a better argument on that?
I feel bad.
I think you can.
Yeah. I could maybe if I were like, I don't think of this. I guess I don't really have a great answer for either. I don't see those two as necessarily kind of connected, I guess. And maybe that's just because I'm not seeing it as you're imagining it. But I don't see, I think even if you're obviously we want to keep our AWS costs or our cloud cost low, and so even if we're just spending, $10 or $20 a month or something on the actual infrastructure to say produce our not heavily trafficked AWS Lambdas and things like that, I still think it's valuable to have a team to have a plan or whatever that lets you work as a team without, so I don't see those things as necessarily connected, that what you're spending on infrastructure, maybe the amount of infrastructure you're using, the amount of code you're trying to manage, certainly that definitely, the amount of resources you're trying to manage, certainly that makes sense to me. Like if you're just, a couple of, few developers and you've got one virtual machine that is your production instance and, one that's, each of you has a dev instance and you're just kind of doing that manually. I'd say go keep doing that. If that's fine, but when you've got, you're using some EC2 and you're using some Lambda, you're using some API gateway and some buckets, maybe you've got 3 or 4 or 8 buckets. Okay. That's when it's like, you should do it in code as we described. And then if you're all wanting to use, iterate on the same code base constantly or often, it makes sense to use, the service, for example, to keep you all from, overriding one another's work and things like that. And then, beyond that, as I described, when you have larger teams that, need to have their access to different things controlled, then it definitely makes sense to look to something like the service to be able to control that access. So I hope that answers your question. I mean, I'm not trying to dodge it by any means. I just don't have.
No, I think you kind of said what I was looking for, which is don't think of this in relation to your server costs. Think of this in relation to your team productivity costs.
Yeah, team productivity definitely, and I think that team productivity is definitely related directly to the amount of time the team would need to spend managing infrastructure stuff. So yeah.
Yeah, if this is saving you $50 a month in terms of manual processes or team communication, or because what one person is going to be somewhere between $20 and $60 an hour. So if it saves one or two people 1 hour per month, then it's worth it.
Yeah, I think that's a good way to sum it up. Yeah,
cool. Because I did want to get some sort of resolution on the idea of, what's the ideal scenario, or how can we frame this as when somebody should go for it. And I feel like through all of that conversation, hopefully that got tied up. Steve, what do you think? Are you sold?
Absolutely. What am I sold on?
Oh gosh. I'm at a point where I might give this a try myself. So don't call it a celebrity endorsement yet, because there's not any celebrities on the show, especially not me. But
that's great. I mean, again, and I work for Pulumi, but it's, I don't care. I don't care if you pay for this or anything like that. I just want to get people to want to try to do infrastructure things with code, especially with JavaScript, because it's just awesome. If you're going to go and try it, that's great. That makes me I'm legitimately smiling right now, because I want to encourage developers to try this stuff.
I'm going to look up how I might be able to use it with name.com and DigitalOcean, because that's what I like to use, because I find them to be the simplest to use in their web interface.
Yeah. I mean, the DigitalOcean provider for Pulumi is definitely first-class provider. So you'll see lots of examples in the docs and stuff that deal with DigitalOcean. So,
and if name.com isn't in there, I'd be willing to try DN Simple. I hear good things about them. But anyway, yeah. So I understand this wasn't a sales pitch for Pulumi, but I'm just, I often on the show, as you probably heard in the past, because you said you've been a listener, I bring in the hard-hitting questions about how do we justify the value of this?
I was expecting that. Yes. So yeah, that's great.
Anyway, cool. Thank you.
Yeah, absolutely.
Hey folks, I don't know if you've noticed, but I've been working a lot on figuring out how to help people become the most valuable developers on their teams, or becoming the top 5% of developers in the field. If you're looking to level up, figure out how to contribute more, get the career you want, get the career that you want that will support the lifestyle you want, then you should check out the Most Valuable Dev Summit. I've invited some of my friends across the community, people that you've heard of, people that have worked on systems that you use on a daily basis, people who have invented new ways of doing things over the years in programming, and I've asked them one question, and that question is, how do you become a top 5% developer? How do you become 1 in 20 of the best developers out there? And so we're going to go ahead and have that conversation with them in interviews on the Most Valuable Dev Summit. And you can find that at summit.mostvaluable.dev.
I guess it's time to push us into picks. AJ, do you want to go first?
No, because I actually don't have my picks ready yet today.
No.
A minute.
Steve?
So I'm going to go with the simple as usual. So I was listening to another tech podcast, a pretty well-known one. And one of the topics that was brought up was called nerd sniping. It's basically getting somebody, the idea is that, you're working on something and then something comes to your attention that's right up your alley, something you're really interested in. You forget what the heck you were doing and go just focus on that. So probably one of my all-time favorite classic SKCDs is called Nerd Sniping. It's it goes way back to probably one of the first ones, number 356, if you know how his URLs work. Cracks me up every time I see it. I'm also into the real physical type of humor. So yeah, check it out, xkcd.com, number 356.
Awesome. AJ, are you in a place to have some?
Give me 30 more seconds.
Okay. I am combing my GitHub stars recently, and someone passed this to me at work yesterday. It looks pretty good. It's awesome. All these people have the different awesome GitHub repositories, and this one is awesome network automation. I'm curious if I see Pulumi on here, but I don't have time to look right now. But if not, you guys probably should get yourself added, and it looks like there's a lot of good resources on here. So cool. That will be it for me, and hopefully AJ is now in a good spot.
Amy, I've been really meditating over the past 30 seconds, and I feel like now I'm in a good place to share some picks.
Good.
I really had to, but I'm in a good place now. Okay, so first of all, I'm going to pick the Bound app because, as many of you know, I hold off on new technology as long as I can. So I finally updated my laptop to Catalina, which is where I've got most of my audiobooks that I sync to my phone. And of course, Catalina screwed up everything about my computer. Now it crashes instead of going to sleep, and all sorts of stuff, because it's a 2012. I like having the ports on the side, not the dongles. And anyway,
it's just making sure it really goes all the way to sleep. Just think of it that way.
Yeah, I guess so. Except when it wakes up, it's always like, computer shut down unexpectedly, submit a crash report. Or rather, when I plug it into power and hit the button and whatever. Anyway, so a lot of people that are into audiobooks have been complaining about, Catalina just screwed up the audiobook stuff, and you can no longer manage it in iTunes, and and you have to have duplicate copies, and it has to put in its own folder. It doesn't work the way it used to. So the Bound app has this really cool feature where it lets you upload just the files to your phone through a web browser. So you go into the setting and you say like start web upload server, and then it gives you your IP address on your local network, and you type in 192.168.1.105 or whatever. And then you drag and drop, and you can, drag and drop folders, and you can get audiobooks onto your phone that way. And it's actually, some of the features of it are a little bit nicer than the native iBooks app or the Audible app, especially the speed settings and the sleep settings were pretty intuitive for me. I mean, not that they're like that earth-shattering anything. And then also I found out that the VLC app has the same feature for your music. So you can actually, and both of them work with like Dropbox and Google Drive and some of the stuff like that as well. But they both have this neat feature where you can web upload, and the VLC app actually has, the source code online. So you can go check out how that kind of thing is done in an iOS app, which is pretty cool.
Whoa,
and then
dude.
Since we've been talking about, this deployment and infrastructure stuff, I work mostly with startups and smaller teams and smaller companies. And so I'm realizing I need to get on this, infrastructure as code bus. I'm like having that moment of humility. It's been working on me, but I'm getting there. But me and a buddy of mine, what we've been using for a lot of our client work is Git deploy, which is something that we created ourselves. But it's really simple. It works with webhooks like GitHub and GitLab. I don't remember if it's GitLab or Bitbucket. We've got like 3 or 4 of them integrated in there because we just work with various clients, and then we add one. But you just set the thing up, you put it behind Caddy for, so you get the HTTPS or whatever. So we've got a bunch of sites where it's like gitdeploy.whatever.com. We set up the webhook to that, and then it fires off a bash script that runs the build process whenever a push comes in according to a couple of rules. So if that sounds, more your speed, it's something to check out. But in the day and age and where we're at, you're probably better off spending that time on something like Pulumi, if I'm being honest. But just, if you want it, it's there. That's webinstall.dev/gitdeploy.
Cool. Should I go?
Go ahead with your picks.
I have non-technical picks. The one is, I haven't listened to this podcast in a little while, like a few months. And so I just want to share, like we just finished watching a series called Schitt's Creek. So I'm probably late to this, but like my wife and I absolutely loved this series. So if you haven't seen it, if your listeners haven't seen it, it is an absolutely lovely comedy series on Netflix that I can't recommend highly enough. It started out a little bit rough for us, and we weren't sure if we were going to like it, but at the end, man, it's just such a beautiful story. So like, I recommend that as a thing to watch on Netflix, Schitt's Creek, if you're so inclined and haven't seen it yet, because there may be 2 or 3 people that haven't seen it yet. The other thing that I would recommend is a book, and it's called The Sense of Style by Steven Pinker. If you're interested in writing yourself and maybe writing a book or just writing sort of nonfiction stuff in general, this is a fantastic book written by a really excellent writer who's just a ton of fun to read. And it's all about just crafting good nonfiction that is coherent and easily read by people. It talks about grammar. It talks about the way that we read and how we understand and assemble meaning as we read. And it's particularly geared toward, like I said, nonfiction writers that are explaining how something works and so on. So I cannot recommend this book highly enough. I've probably read it 3 times myself in the last year as I've been working on this book. So if you're interested in writing The Sense of Style, Steven Pinker, you will love it. It's great.
Awesome. Thank you. I guess with that, we will wrap up. Thank you so much for coming. Hopefully people are also convinced now. Sounds like AJ is, maybe Steve too. I know I'm trying to convince people, so appreciate it.
Awesome. Thank you so much. I'm so grateful to have been able to talk to y'all. So I appreciate it so much.
Let us know before we say goodbye, where can people find you or more information about all of this?
Yeah, I'm C Nunciato on Twitter. So CNUN CIATO on Twitter. I don't do a lot of tweeting. When I do, it's usually about JavaScripty things or Pulumi related infrastructure things. So you'll find me there. And my website is linked from there too, where I post a lot of pictures. I take a lot of pictures of the Northwest and so on, and my family stuff. So if you're interested in the Northwest and the geography here and the beauty of it and stuff, you can see some pictures of that on my website. But yeah, I'm on Twitter. You'll find all the important things there, I think.
Awesome. With that, we will see everybody next week. Bye.
Adios.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.
At Kroger, we know the minute a tomato is picked, the fresh timer starts. The sooner we get our produce to you, the fresher it is. That's why we've shortened the time from harvest to home for our tasty tomatoes, strawberries, and salads. So no matter how you shop, you have more time with your fresh produce. Kroger, fresh for everyone.
Save big on your favorites with the Buy 5 or More, Save $1 each sale. Simply buy 5 or more participating items and save $1 each with your card. Kroger, fresh for everyone.
Finding great candidates to hire can be like, well, trying to find a needle in a haystack. Sure, you can post your job to some job board, but then all you can do is hope the right person comes along. Which is why you should try ZipRecruiter for free at ZipRecruiter.com/post. ZipRecruiter doesn't depend on candidates finding you. It finds them for you. Its powerful technology identifies people with the right experience and actively invites them to apply to your job. You get qualified candidates fast. So while other companies might deliver a lot of hay, ZipRecruiter finds you what you're looking for. The needle in the haystack.
See why 4 out of 5 employers who post a job on ZipRecruiter get a quality candidate within the first day. ZipRecruiter, the smartest way to hire. And right now, you can try ZipRecruiter for free. That's right, free. At ZipRecruiter.com/post. That's ZipRecruiter.com/post. ZipRecruiter.com/post.